This next section of notes is going to be dealing with bar graphs, pie charts, and percent change. And honestly, it's almost identical to the section that we're going to start tomorrow in statistics over charts, okay? So all of chapter 2 in statistics is dealing with ways of organizing your data, and they're dealing with visual graphics, all right? So let's look at this first one. It says, the bar graph shows the number of new residents in several towns during the years of 1999 to 2001. Use this graph to answer the questions. What was the decrease in the number of new residents in Hattiesburg from 2000 to 2001? Keyword being decrease. What are we going to do with these information? We're going to go to Hattiesburg. We look at 2000 and 2001. What are we going to do with those two numbers? Subtract them. So since we want to know the decrease, we want to say, okay, we were at 143 new residents at one point, but then we went down to 111. So what is that difference there? What do you guys get when you do that? 32. And again, since it is kind of like a word problem that goes with it, we would say 32 new residents. So anytime they use the word decrease or difference or change, like you're comparing, it's always going to be subtraction there. Let's look at number 2. It says, what was the total number of new residents in Burton during the years 2000 to 2001? Keyword meaning total. So what are we going to do with Burton's values on 2000 and 2001? Add them. So we're going to take the 2098 new residents and the 2001 165 residents and add them together to see how much total they had in those 2 years. What do you guys get when you do that? 263? Is that what you guys get? 263? So just double check that. Sometimes we hit the wrong numbers in there. Yeah, I was like, I did. All right, so then 3 was, what was the total number of new residents in the Hattiesburg and Crowley during the year 1999? So this one's a little bit different. Instead of looking at one city and pulling 2 values off, we're actually looking at 2 different cities. So we're going to find the total again. So we're going to go to Hattiesburg for 1999. That was 76. And we're going to go to Crowley for 1999. That was 163. And we already know what to do with the word total. We're going to add those up. Do you guys get 239? Does that look right? All right, so those are just kind of the different ways to look at it. So you can compare, and when you compare, you're going to subtract. You can total, and when you total, you add. And notice you can either look at one city multiple times or 2 different cities in the same year. So there's different ways we can do that. This is called a side-by-side bar graph that we'll learn in section 2.1 tomorrow. 4, the figure represents a survey of favorite foods. So this kind of goes with what we were talking about yesterday. This is not an open-ended survey. Notice we have, was it 5 things they can choose between? Burger, pasta, burrito, a hoagie, or a pizza, right? So we're forcing them to choose one of the 5. The question is, what percent of the votes were for burritos? Well, this is something that we haven't really talked about. We kind of mentioned it briefly on Wednesday. But anytime you need to find percent, guys, the total or whole will be on the bottom, and your part will be on top. Okay? Once we get that fraction, we'll change it to a decimal by dividing, but then we'll multiply it by 100 to get the percent. So how many total people did we ask on the survey? 500. Is everyone okay with where Corey got that? Okay. So we just have 500. All we did was, those are everyone surveyed. But of those 500, which ones do we care about? We care about the burritos. Okay. And how many of people voted for a burrito? 90. Okay. So if they asked for a reduced fraction, you'd put 90 over 500 in your calculator, you hit math frac. But they're asking for a percent, which means we need to go from a fraction to a decimal and then a percent. So what we're going to do is divide. You get 0.18, I believe? Yeah. Okay? So if they ask for a decimal, it'd be 0.18, but since they want a percent, what do we need to do to that number to get it to a percent? Multiply by 100, move your decimal over 2 spots, whatever it may be, and don't forget that percent sign, right? So times 100 will get us to 18%. And again, the whole idea here, guys, is pizza, this is called a pie graph, actually. are very good visuals, but a lot of times we just look at those numbers and those numbers don't really mean anything to us. But if I say, okay, 18% of the people liked burritos, you kind of have an idea, okay, that's about 20%, roughly 1/5, and it's a little bit easier versus just these random numbers there. Are there any questions on the front page? Go ahead and flip it to page 2. This is going to be the exact same thing as number 1, really, okay? So we have 2 things going on. The left bar is for males, the right bar is for females, and this is the number of athletes in a university over 4 years, all right? So the question is, which year had the greatest number of male athletes? So we're only focusing on the left bar. Which one has the highest left bar? 2012. So the greatest number of male athletes is right here at 2012. Next part is not a number. Which year had the smallest number of female athletes? And that's when you realize you want to focus on the right bar where they have the F. Which one has the smallest right bar? 2009, right there. And last but not least, which year had the same number of male and female athletes? 2011. Again, we are going to reiterate all of this tomorrow because a side-by-side bar graph, you can look at it in 3 different ways. Individually for just males, individually just for females, or comparatively between the 2. And that's what we did with these 3 options. Are there any questions on that one? We okay? Like I said, this is pretty easy. Just kind of make sure you're focused on what you need to pull from that graph. 6, in a school survey, students showed that they preferred these instructional materials. So this shows you the percentage of what they prefer when it comes to the teacher teaching. So it says, about how many students would you expect to prefer films in a school of 350 students? So all we know right now is this pie chart that tells us the percent of students that prefer these. And then we can go from school to school and say, okay, this school has 350, this school has 8,000, and we can get a rough idea of how many people prefer that. So we care about, what is it, films? So films is right here, 20%. So we want 20% of 350. So this goes back to when you used to do word problems. 20% of means multiply, okay? But you're going to quickly find, guys, in this class specifically, that we never really do math with percents. Percents are like a pretty way to display information because we can like comprehend it. But when it actually comes to computing, we always want percents as decimals, bless you. So what is 20% as a decimal? 0.20. Of means multiply 350. So anytime you have a total amount and you want to know a certain percent of that total amount, you're always going to multiply using the decimal equivalent, all right? So if you put 0.20 times 350 in your calculator, what do you guys get? 70. Was it 70? And then it'll ask what 70 students. So is everybody okay with how we went from 20% to 0.2? Hence the lesson we covered on Wednesday, right? All hopefully will go hand in hand. We simply divided by 100. So you'll see this on your worksheet. You'll see it on my math lab. You'll see it in stats. You're going to be given a percent of this class. There's 18 of you. What percent have black hair? And what you'll do is you'll take, or excuse me, you'll say 20% have black hair. How many students have black hair? And you can multiply that by the 18. All right, so this is where, like I said, it starts to get a little bit more tedious because instead of having a graph to look at and pull answers off of, we're creating that graph, all right? So let's look at what's going on here. It says 50 people participated in a poll to determine their favorite kind of ice cream. Again, it's forced. If I was asked my favorite ice cream, I would not pick any of those 3. Would anybody pick any of those 3 for their favorite? If you had option, what would you like, Lexi? Chocolate. Anybody prefer chocolate, vanilla, or strawberry? Like I'm like Moose Tracks or something crazy like cookies and cream, that kind of idea, right? So it's really forced. So we don't know how accurate the results are. Key thing here is to realize they actually gave us the total number of people right here. We got to keep that in mind. The total was what? 50. Okay, which is kind of hidden because it's written in words instead of that number. So in order to make a graph, we have to be able to say, okay, well, how many were in each category? All right, now that we know how many are in each category, what percent were each of those people? How do we do that? It's exactly what we did like on number 2 on this worksheet. We knew we had or 4, I guess the number 4. We knew we had 500 people that we asked and 90 preferred burritos. So we asked how many people? 50 and 20 prefer chocolate. So how are we going to come up with that percent? We're not going to multiply by 100 because we don't have a number yet. Divide it by 50, then multiply by 100, right? So we'll say, okay, 20 divided by 50 equals 0.4, right? 20 divided by 50 equals 0.4. But that's not a percent. So what do we still need to do? Multiply by 100. And we get what? 40%. And now that's a little bit more doable. You're like, okay, I asked 50 people, what does 20 mean? Well, 20 of 50 is 40%, almost half. Guess what we're going to do with strawberry and vanilla? Exact same thing, okay? So we take each of those, 12 and 18, divide by 50. Once you get that decimal equivalent, guys, multiply by 100 to get your percents, okay? So 12 divided by 50, I got 0.24. Does that look right? So times 100 gets us 24%. 18 divided by 50, was that 0.36? Yeah. Times 100 will give us 36%. Something to keep in mind as you're working on these are everyone we asked, right? They total up to 50. So what should our percentages add up to since they're everyone? 100%. So kind of keep that in mind as you're doing it. All right, so this is what I was talking about. We eventually want to draw a pie chart or a pie graph. And in order to do that, we need to know how big our slices are to make them. And so what do we know about the number of degrees in a circle? 360 degrees in a circle. So what we want to do is we want to take a percentage of that 360 degrees to know how big these slices are going to make. But don't we already kind of have the percents as decimals already? So all we know is that this circle is made up of 360 degrees, but 40% of that circle is going to be for chocolate. So we're just going to take each of our decimal equivalents that we had right here, 0.4, and multiply by 360 degrees to say, okay, well, what is 40% of 360 degrees? How many degrees do we need to draw this bad boy? 144 degrees. And guess what we'll do for strawberry and vanilla? The exact same thing. Take that decimal equivalent, so we know it's 24% of strawberries, but remember, we never do math for percents. We always change them to decimals first, okay? So we're going to use this 0.24 times 360 degrees. And let's round to the nearest tenth. 86.4 degrees is what I got. Does that look right, guys? Okay. And then we'll do it one more time, but with 36%. And we'll just say, okay, well, what is 36% as a decimal? We have it right here. It's just that 0.36. So we'll do 0.36 times 360 degrees, round to one decimal, and you get 129.6 degrees. All right. Are we going to actually draw it right now? No, but we kind of have a rough idea. If we have our little protractor, we could measure around 144 degrees, draw our pie slice, and so forth, and we'd get the equivalent proportions. So let's just keep in mind that the number of degrees in a circle are 360 degrees. And I'm not going to worry about drawing that right now. But all right, so the next thing is one more concept that we haven't talked about. Sometimes we don't care about how much things increase or decrease. It really, where the kicker is how much that decrease or increase compares to where you originally started. So maybe you got a raise and it was only a $5 raise, but you started at $10. So $5 raise is huge. That's 1.5 times, and that's kind of the concept here. So sometimes the amount doesn't seem that big, but compared to where you started, it's a big deal. So anytime you see percent increase, any of that stuff, percent change, what we're going to do is we're going to use a formula. Let's see if I can write it over here. I know there's not a whole lot of room. So the formula, guys, is new minus old over old. Okay? So it means take that new value and subtract the two and get your amount of increase or get your amount of decrease, all right? But then go back and compare it to what you originally started with. That's what we really care about. At the very end, guys, that will be a decimal, so we won't forget if we want to change it to percent to multiply by 100 at the end, okay? So notice all these are your original amounts. That's considered the old. And all these are your new amounts. That's considered the new, all right? So say we went from, I don't know, like I'm signing up my daughter for gymnastics, okay? So say the class used to be $60 a session, but now it's gone up to $90. Some people might say, oh, well, that's only $30. I'll be like, $30 compared to the $60 I was paying, that's a big increase. So let's see how big of an increase it is. So what we're going to say is new minus old over old, okay? So we're going to do 60, oops, sorry, that's not the new, I lied. We're going to do 90 minus 60 over 60. Oh, I'm sorry, I'm messing this all up. I'm not reading, sorry. I didn't want you to jump right into here to get to the percent increase. I'm not reading my column correctly. The column just wants to know how much did your price increase. We went from $60 to $90. What is that difference? 30. That's my fault. I'm sorry. So realize this is the new minus old column, okay? This is filling in this top row, all right? So my gymnastics class went from $60 to $90. It's a $30 increase. But what kind of percent increase is that? I'm going to compare it back to my old. So I do 30 over my original of 60 times 100 to get a percent. Okay? Why am I 60? Because you always compare it to that original amount, right? So what do you guys get when you take 30 divided by 60? Do you get 0.5 times 100? 50%. So even though some people might say, oh, Molly, stop complaining, it's only $30, I'm like, that's a 50% increase. Like, I was paying $60, and then they added 50% of that back on for this new amount. That's a big increase. All right, the next column, guys, how do we go from 6 to 21? What's our increase there? How much did we go up by? What was it? 15. Okay. And again, someone might say, oh, 15, that's barely anything. But 15 compared to my 6 that I was paying originally, that's huge, okay? So what we're going to do is we're going to take this difference of 15 and compare it back to our old. So 15 over 6 times 100. Look at this bad boy. Do you guys get 250% there? That means that's 2.5 times. Just the amount of increase is 2.5 times more than what you were paying originally. All right, 75 to 80, how much did we grow by? 105. Does everybody see where these numbers are coming from? It's just the new minus the old, right? We're going to take this new amount minus the old. But then whenever you need to get the percent increase, you're comparing this difference to your old. So we're going to put 105 to that 75 that we had originally and multiply by 100. You guys get 140% there? Does that look right for those that are working ahead? All right. And then the last one is, okay, how much did we go up by if we went from 116 to, say, this could easily be like your tuition, right? Price per credit hour. Maybe they were charging $116 when you started here, but now they're charging $377. How much of an increase is that? Well, that's a $261 increase or whatever this is representing. But not only is that increase important, it's like, look at it compared to him. It's more than double it, right? So we're going to get a percent that's more than 200. So take your increase, 261, and divide it by your original. Do you guys get, is it 225 perfectly? Yeah. Or did I round? Okay. Oh, this is what I wanted to talk about. We talked about it on Wednesday, but I don't know if we ever kind of saw it happen. Notice on the instructions it says round percents to the nearest tenth if necessary. That means do your division and then multiply by 100 and then round, right? So sometimes we'll do a division. The reason why I'm pointing that out is because on our worksheet you might get like 0.7 repeating and you round it to 0.8 and then multiply by 100 and you say 80%. But really they want you to take 0.7 repeating times 100 and get 77.7 repeating, then round. So 77.8% is different than 80%, okay? So be careful. This is always at the end. All right, so the next one is round, again, the percents to the nearest tenth, dollar amounts to the nearest cent, and all numbers to the nearest whole. The number of video stores in a region recently decreased from 70 to 52. Find the percent decrease. So anytime you see the percent decrease, the percent increase, it's this formula. New minus old over old, all right? But this time, instead of going upward, it's going down. Like how many Blockbuster's no longer, right? How many, I think Family Video's the only one around. Do you know why? I'll tell you when this isn't on, okay? Remind me to tell you why that's the only one around. Somebody told me this, and I believe it. All right, so we're going to do new minus old over old. And we'll say, well, what's the new amount of video stores that are out there? It went from 70 to 52, right? What was the old amount that it had? 70. So we're going to do this and get a difference of, what is that, negative 18. And we're going to times it by 100. When you do that, guys, what do you get for your value? I don't have the exact number. What do you guys get? So order of operations, right? We want to make sure we do that subtraction first to get that difference of negative 18. Make sure I did my math right there. But how does that difference of 18 stores compare to the 70 that we originally had? So you do this and you get 25 point blah, 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 right? Okay? So this is where you round. So it says round to the nearest tenth. The tenth is just one decimal point. So I think it's a 7. What's behind the 7? A 1. So it's just going to stay 25.7%. And you can put the negative there. I'll talk to you about this, okay? You can put the negative there, but you actually don't have to. And actually, I think my math lab might yell at you if you do. Because if they say percent decrease, they know it's going down, right? And so they don't need that negative. If they say, what's the percent change? They don't know which way you're going. So I'm just going to write this right here. This is not needed. Purposes of my worksheets for my test, if you put a negative there, it is not wrong, okay? You're following the formula, new minus old over old. And since we're going down, new minus old is going to be a negative number, all right? So just keep that in mind, though, because that can be frustrating when you're doing my math lab. You think you did the math wrong. No, you're adding a negative when they don't want that negative there, okay? So percent change is where you have to show the difference between a positive or a negative. But percent decrease or increase, they're telling you what they know.